Another way of estimating errors when the actual value is unknown is by calculating the measurements with their uncertainties. So what is uncertainty? Uncertainty is the range of possible values within which the true value of the measurement lies. For example, we have this measurement, would have this measured value equal to 10.0 plus or minus 0.05 centimeters. So this is our measured value, and this is the uncertainty of this measured value. So remember that the uncertainty of measured value is provided or determined from the measuring device you are using. So this measured value means that the true value of the length of the object lies between 9.95 centimeters to 10.05 centimeters. So, paano natin nakuha si 9.95? So, we subtract 0.05 from 10. So, 10 minus 0.05, we will have the lowest possible value is 9.95, and the highest possible value is 10.05. So 10 plus 0.05 is 10.05 centimeters. So the true value lies within this range. So dyan pwedeng mahanap yung possible actual value ng measurement. So remember that when we are measuring, our measurement is never exact. So that's why there are uncertainties in our measurement, and we can use these uncertainties to estimate the errors. So uncertainty is a way of expressing our confidence in our measurement. So depende sa value ng uncertainty natin, so masasabi natin that our measurement would be precise, or our measurement is accurate. So our measurement is precise. So yan. So any measurement that disregards the measure of uncertainty is meaningless. So especially in application, we need to consider the uncertainties of measurements. So for example, in engineering, so yung mga engineers natin, when they are measuring quantities or properties, physical properties, the quantity of the measurement are always accompanied by the uncertainties. So measurements always have some degree of uncertainties due to unavoidable errors. Thus, while error is the measure of deviation from the true value, uncertainty is the way of expressing these errors in our measurements. So the relationship between error and uncertainty is demonstrated by the equation. So the measured value, this is our measured value. So the quantity of measurement plus or minus uncertainty unit is equal to the measured value, wherein our measured value could give us could be the highest possible and the lowest possible value. So we have here plus minus uncertainty, and in symbol we make use of Q to represent the quantity of measurement and delta Q to represent the uncertainty. So we can also use other letters than Q and other letters than Q. So for example, length, we can use L in length for the quantity of length and delta L for length. Or for example, volume, delta V for volume, or delta B for the uncertainty of volume, and V for the quantity of volume, or A for area and delta A for the uncertainty of the area. So this one is quantity then multiplied by the unit. So do not forget the unit when you are writing the final measurement. So there are two ways of determining the uncertainty. So first is using the least count, and second is by using the range method. So least count is the smallest value that can be read from any measuring device. So as a general rule, uncertainties must be reported with the same number of decimal places as the instrument used. Thus, uncertainty is plus minus the least count. So yung least count natin, ito siya. So in recording your measurement, it must contain the numerical value or the quantity of the measurement, so Q, and then plus or minus the degree of uncertainty in the measurement, so plus or minus delta Q, and don't forget the units. So this is how we write it in symbols. So the least count for the digital measuring device, yung kapag ginamit mo yung measuring device na yon, hindi mo na kailangan tignan pa yung mga linya-linya or the graduation, because yung mga device na yun, measuring device, will already tell you the number. So makakakita ka na ng number instead of you reading between the lines. So literal between the lines. So for analog measuring device, so for digital measuring device, the uncertainty is simply the measure of the least count. So kung ano yung smallest possible value na pwedeng ma-measure ng measuring device, yun ang least count ng digital measuring device. But for analog, the uncertainty is 1/2 the measure of the least count. So yan, that's how we get the uncertainty for analog measuring device. Kapag analog, that is yung manual kang magbabasa. So hindi sa'yo binibigay ng measuring device yung tawag dyan, yung numbers of the measurement. For example, for the digital balance, yan. So digital balance, so nakikita nyo, number na yung nakikita nyo. Unlike for this kitchen scale, so this is an analog weighing scale. Yan. So dito, i-determine mo pa. So yan, 100, 200, 300. So ikaw pa yung magbabasa, magde-determine kung ilan yung timbang nito. But for the digital, given na ng mismong timbangan. So hindi ka na maghihirap pang at maduduling kakabasa kung nasaan yung pointer or kung nasaan yung end nung bilang. So again, for the digital, ang least count niya is the smallest possible value na pwedeng ma-measure nung device. So for example here, so ang mass nitong banana, nitong saging is 15.4 grams. So ito yung smallest count na pwedeng maibigay nitong digital balance na to. So meron siyang 1 decimal place after the whole number. So since meron siyang 1 decimal place after the whole number, ano kaya yung smallest possible na timbang na pwede nating makuha? So the smallest possible is 0.1 grams. So since this is a digital measuring device, the least count is equal to the least count. So, smallest possible value that can be measured. So 0.1 grams. 15.4. So to write the final measurement, we have 15.4 plus or minus 0.1 grams. So the true value or the true measure of the mass of this fruit is within the range. This range of 15.4 minus 0.1 or to 15.4 plus 0.1 grams. So on the other hand, for the analog, so we have here an example for the analog, a weighing scale or a kitchen scale. So we have here a deflection, may pang deflect. So itong pointer na to, so we use it to know kung nasaan ba tumigil, kung ano ba yung timbang nitong prutas na to. So the least count for analog is this one. So 1/2 the smallest possible value, the smallest calibration of the of the measuring device. So dito, ang smallest calibration nito, so let us zoom in our weighing scale. So we have here 0, next is 100. So ibig sabihin, from 0, ang interval from 0 to this line is 100 grams. However, 100 grams is not our smallest calibration. So our smallest value here is this line. Ayan ang mga maliliit na line. So from 0 to 100, ano kaya yung mga value nitong line na to? So for example, 1, bilangin natin yung linya. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have from 0, tumaas tayo ng 10 graduation. So since the last graduation is equal to 100 grams, 100 grams divided by 10 graduation, then we'll get 10 grams. So that is the smallest calibration natin dito. So that is the smallest possible value that can be measured by this one. So smallest possible value that we are certain. Yan. So 10 grams, and then since sabi natin we need to, for example our value lies between 100 and 110 grams. Ayan. So this line, for example, andyan. So saan ba siya mas malapit? So is it closer to 100, or is it closer to the next graduation? So we need to look for the halfway point and to determine whether our least count or our value is closer to the next graduation or closer to the lower graduation. So we need to multiply the smallest possible value or the smallest calibration by 1/2. So the least count is 5 grams. So 5 grams will become our uncertainty. So since the measure, so dito kung titignan natin yung ano niya, saan na yun? Ay, sorry. Okay, so since andyan, kung titignan natin yung measurement niya, so this line, this long line is 600, next small line is 610. So ang estimated timbang nito is 610. So ano yung yung uncertainty natin, kasi nag-estimate lang naman tayo. So ano yung uncertainty nung measurement natin? So the uncertainty is plus or minus 5 grams. So meaning the true mass of this fruit, of this banana, nitong saging na to, is within 605 grams to 615 grams. So to get 605, we subtract 5 from 610. To get 615, we add 5 grams to 610. So the true value of the measurement of the mass of this fruit is within 605 to 615 grams. Yun yung ibig sabihin nito. We have uncertainty of 5 grams. So let us have a concept builder. So a while ago, we determined the estimated value or estimated volume for these liquids. So sabi natin, it could be 47 to 48 ml, and this one is 21.5 ml. So ginamit ko na lang dito sa isa is 48 ml. So how do we determine the uncertainty? So sabi natin that the uncertainty, so this is so to determine the uncertainty, we need first to identify whether the measuring device is an analog or a ang tawag doon, or a digital device. So a beaker, kapag naglagay ka dyan ng liquid, nagbibigay ba yung beaker ng number sa'yo? So hindi naman. So therefore, this is an analog device. The same with graduation cylinder. So, kapag naglagay ka dyan ng liquid, hindi naman magsasalita o magdi-display si graduation cylinder ng exact amount ng volume ng liquid mo. So, therefore, this is also an analog measuring device. So, for measuring the volume of liquid. So, these both are in milliliters. So, to determine the uncertainty, we need to determine first the least count. So, for analog device, the least count is 1/2 the smallest calibration. So, the smallest calibration here is, so this line. So, this, if the first line here represents 20 milliliters and the third line represents 40 milliliters. So, anong number tong nasa gitna ni 40 and ni 20? So, yan. So, 20 plus 40 divided by 2 is equal to 30. So, 40, 20, 60 divided by 2 is 30. So, therefore, from 20, pagdating dito sa next line na to, itong maliit na linya, this is 30. So, meaning, tumaas tayo ng 10 ml. So, ibig sabihin, the smallest calibration in this beaker is 10 ml. So, since this is an analog device, we multiplied it by 1/2. So, therefore, our uncertainty is 5 ml. So, now, our estimated measured value is 48 plus or minus 5 ml. So, that is the measure of this, the volume of this liquid. So, for the graduation cylinder naman, so, the smallest calibration is, for example, 20. So, this next line is 25. So, ano tong, ilan ba ang interval between this graduation? So, 20, 21, 22, 23, 24, and 25. So, yung ano natin, so by the way, so, kapag nagbabasa kayo ng ang tawag dyan, when you are determining the volume of a liquid using a graduated cylinder, graduated cylinder. So, pag nagbabasa kayo, magbase kayo dun sa lower meniscus. So, yan, lower meniscus. So, the lower meniscus is found between 21 and 22 ml. So, our estimated value is 21.5 ml. So, what is our least count? So, to determine the least count, so 1 ml, the smallest calibration is 1 ml divided by or multiplied by 2 or divided by 2 to get the value of the least count, which is equivalent to our uncertainty. So, 1 ml divided by 2 or 1 ml times 1/2 is equal to 0.5 ml. So, our uncertainty is 0.5 ml. To write the final measure, so 21.5 ml is our estimated plus or minus 0.5 ml. So, yan. Another way to determine the uncertainty of measurement is by range method. So, range method is used when we have trials, data sets. So, range method is a way of determining uncertainties in measurements that only applies to averages of repeated measures if we have multiple trials. So, instead of determining the individual uncertainties of each of these measures, we just look for the difference of the lowest measure and the highest measure, and then divided by 2. So, here's how we do it. To determine the uncertainty of repeated measures, such as this one, subtract the lowest measurement from the highest measured value. So, yung lowest measured natin dito is 20.5 at ang highest measured value is 22.3. And then, next step is to divide the difference into 2. So, example. So, let's take the data in table 1 and identify the highest and lowest obtained values. So, ito na yung highest and lowest value natin. We get the difference of these two, 22.3 ml minus 20.5 ml is equal to 1.8 ml. And then, we divide 1.8 ml into 2. So, by dividing it into 2, we get 0.9 ml. Now, this number, this value will correspond to our uncertainty. So therefore, the measurements is the uncertainty of the measurements is 1 positive negative 0.9 milliliters. So ano yung natin dito quantity before this one? So the quantity here, so the estimated value here is ayan. So we have here the average. So, yun yung ilalagay natin dito. So, to report this measurement, to report the measurement of repeated values, repeated measurements, get the average of the obtained values, then plus or minus the uncertainty. So, we get the average of this data set. So, the average is 21.5 plus or minus our uncertainty, which is 0.9 milliliters. So, this means that the true value, so the most probable value closest to the actual value is within the range of 20.6 ml to 22.4 ml. So saan nakuha yung 20.6 ml? So we get this by subtracting 0.9 from 21.5, and the highest possible value, which is 22.4, we get this from adding 0.9 ml to 21.5 ml. So within this range from 20.6 ml to 22.4 ml, the most probable value or the actual value can be located. So hindi lang natin alam kung alin yung totoong value. So pero andyan lang siya within this range. So to represent this range, at ito yung average niya. So, there are different types of uncertainty. So, we have absolute uncertainty. We have relative uncertainty. So, relative uncertainty is furthermore classified into fractional and percentage uncertainty. Okay, so, absolute uncertainty is simply the least count of the measurement. While fractional uncertainty, so the fractional uncertainty and percent uncertainty are the relative uncertainties, or it compares how large a part of your measurement are your uncertainties. Gaano ba kalaki yung uncertainty mo compared to your measured value. So let's take this example. So a barbecue stick was measured and found to have a length of 20.1 plus or minus 0.05 cm. So this is our uncertainty, 0.05 centimeters, and this is our quantity. So our obtained value, measured value, 20.1 centimeters. So A, find the absolute. B, find the fractional uncertainty. And letter C, find the percent uncertainty. So let's suppose L as the symbol of quantity. So, ito yung symbol of length natin, quantity L. And then, our uncertainty is delta L. Ayan, so delta L is positive, negative 0.05 cm, and our length is 20.1 cm. So, again, dito yan ang galing. So, yan. So, to determine the absolute value, sabi dito, the absolute value is simply the least count. So, therefore, yung uncertainty na meron tayo sa measurement natin, which is given na ito, positive, negative 0.05 cm, that is our absolute value. So, therefore, if we are going to express the absolute value together with our measurement, then we write this measurement. So, quantity 20.1 plus or minus 0.05 centimeters. So, yan yung absolute uncertainty natin. So, while fractional and percent, so we need to do some calculation. So, to get the fractional uncertainty, we divide the absolute uncertainty with the with the measured value. So ito yung measured value natin, and then this is our absolute uncertainty. So relative uncertainty, fractional relative uncertainty is calculated by dividing the absolute uncertainty by the measured value or by the quantity. So 0.05 centimeters divided by 20.1 centimeters, so cancel, eliminate centimeters, will yield to 0.002 centimeters. So to express this uncertainty in our measurement, we just simply write the following: 20.1 cm plus or minus 0.002. So in other books, so most of our books make use of in our setting in Philippines, we make use of percent in terms of expressing relative uncertainty. So to express the relative uncertainty into percent, simply multiply the fractional uncertainty by 100. So 0.002 times 100 is equal to 0.2%. To express the percent uncertainty in our measurement, we simply write 20.1 centimeters, so this is our measured value or quantity, plus or minus 0.2%. So this is our relative uncertainty. So percentage relative uncertainty. The absolute value is the actual measure of the uncertainty and shows how large the error is, while fractional and percentage uncertainty measures how big of a part of your quantity is the uncertainty and shows how large the error is in relation to the quantity or in relation to the true value. Okay, so in our next video, we are going to discuss calculating with uncertainty. So thank you for listening.